Good afternoon, everyone. I'm Abhay from EDS Technologies, and I thank you all for joining our webinar today on how to develop rail vehicle dynamics with multi-body simulation using Simulia Simpack. So before I hand over to our technical presenter, I would like to give a short introduction about our company, EDS Technologies. Next slide. So we are one of the largest technology solutions providers in India. We have more than 30 years of business transformation experience. We transform businesses by helping them uh, to adopt virtual twin technologies, geospatial analytics, and 3D printing. We have introduced many technologies like 3D printing, VR, digital manufacturing, etc., for the first time to Indian customers. We are established ourselves as a trusted partner for more than 2,000 organizations across the country. This is across various industries such as automotive, aerospace, defense, industrial equipment, mining, and more. We have dedicated regional teams who are reinforced by our domain and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. We have a widespread presence with 11 offices across India, which you can see in this slide, with our headquarters being at Bangalore. We are an end-to-end technology solutions providers to our customers. So our speaker for the day is Mr. Anand Kumbhar. So Anand specializes in multi-body simulation with Simpack and finite element analysis with Abacus solutions. He provides technical support and training to customers, helping them leverage these tools effectively for their engineering needs. Currently, he is working as Assistant Manager Technical. He has completed his post-graduation from Rajaram Bapu Institute of Technology, Maharashtra. Over to you, Anand.
Yeah, thank you, Abhay. Okay, so this is the agenda for today's presentation. We will start with the multi-body system simulation, basics of, generally thing of the multi-body system simulation. Then we will go for the what is Simpack Rail, what are the different applications of Simpack Rail. So there are some add-on modules in this Simpack Rail. We will discuss those add-on modules, and then we will discuss the strength of the Simpacks or Simpack Rail. Like why do customers choose Simpack? And there is some competitive landscape. So we will understand which area Simpack is better than its competitors. Okay, so first we will start with the multi-body system simulation, like overview of MBS. So MBS is used to simulate, predict, and optimize the motion and loading of a mechanical system. So MBS helps us to study how a mechanical system moves and how forces act on it. So we can simulate a motion, predict forces, so predict loads and optimize the design. So it simplifies the real mechanical systems and translate them into abstracted models with the discrete bodies, which are connected by joints and force elements. Okay, so in MBS, we simplify them into the mathematical models like discrete bodies. They will represent the rigid or flexible parts, that is bogie frame or wheel set. Then the joints, they will define the allowed motion between the bodies. Then the force elements, they will represent the physical effects like a spring, dampers, and bushings and contacts. Okay, we will understand this with this example here. So this is the real system. Like we can see here, wheel is there, some suspension elements are there. Okay, upper control arm, lower control arm. And this is the MBS representation. Like here we can see we have represented all bodies with this blocks. Okay, rectangular blocks. Like here we can see chassis is there. Then wheel is there. Okay, wheel. Then all this. So here we can see this blue color are the joints. Okay, so how with these bodies are connected to each other, and these red colors are the force elements. For example, spring and dampers we can represent with the force elements. And just by looking at this MBS representation, we can understand how these bodies are connected to each other. So this is called as a MBS representation, or in Simpack we call it as a 2D topology. So generally MBS applications comprise large motions like translations and rotations. So in MBS simulation, components often undergo large movements, including the significant translations and rotations. Okay, so MBS formulations are specifically designed to handle a large nonlinear motions accurately. So in Simpack or in MBS, we have efficient modeling because of the rigid bodies and analytical elements. So this modeling, most components have rigid bodies, which reduces the number of degrees of freedom, and also using the flexible bodies only when where the deformation significantly affects. So system behavior, that is car body bending or long shafts. Also representing physical components with analytical force elements such as springs, dampers, bushing, and contact models. So this approach balances the accuracy and simulation speed, allowing faster simulation event for the complex systems. So what are the benefits of MBS? Like a simulation can be used in a very early design phases to assess the design. It supports the engineering process. So simulation is much cheaper than the prototypes are. So it saves money and allows to break the new ground. Okay. So to break the new ground means you can play around. If you have any idea in your mind, so you can implement that and you can just check it. So like that, you can just check your ideas here. So simulation can be used for scenarios which are too dangerous in reality, like it increases safety and reliability. And this is simulation gives an understanding of the behavior of the whole system, which is more than the sum of its parts. So next we will discuss what is Simpack. So Simpack is used to predict and optimize the motion and loading of any mechanical or mechatronic system, even up into the acoustic range. And see, first application is automotive, Simpack automotive. So in Simpack automotive, here we can go for the ride and handling scenarios, durability or any which scenarios. Okay, we can do that. Then next is the engine, Simpack engine model for engine applications. So if we see here, it contains almost 100 moving parts. Also, it includes the flexible bodies. The next application is Simpack railway vehicle. So this is the first application of Simpack, and Simpack is very strong in railway vehicle applications. Okay, so in railway vehicle applications, we can go for the derailment analysis, ride comfort index calculation. Also, we can go for the critical speed calculation. So we are going to discuss these applications. Then this offshore wind turbine applications, here we can generate the forces acting on these blades of this wind turbine, and then we can check by including the flexible bodies, we can check how much stresses are coming. And this is another example of a rail vehicle, like a roller coaster. So here we can check for the rail and wheel contact. So this is a land machinery applications. Okay, so this is just one vehicle is there, land machinery vehicle. And this is a benchmark kind of example. The vehicle is running over the bump. Okay, some turning is there. Next application is general machinery. Here we can see means drivetrain kind of application is there. So if we see here, this contour plots of this ring or belt is there. So some flexibility of this ring is taken into consideration. So we can include the flexible bodies into this. So Simpack has fast, accurate, robust, and versatile solver, which is helpful for the efficient modeling. So Simpack has a native flexible body integration. See, native flexible body integration. So in Simpack, we can generate the flexible bodies. Means simple flexible bodies or SimBeam kind of examples are there. So we can generate within Simpack. Also, we can import the flexible bodies from the FE software if it is complicated. So Simpack has accurate and stable analysis of high frequency dynamics, means up to acoustic, like noise detection also we can do in Simpack. So Simpack has multi-core support, and it is means a real-time capable application. Okay, so next is we will discuss about the Simpack Rail. So Simpack Rail is a Simpack Rail vehicle is a generic mechanism running on the rails. So Simpack in Simpack Rail vehicle is modeled not as a specific train design, but as a generic multi-body mechanisms. Okay, that moves along the rails. So this means a vehicle is built from the standard mechanical elements such as like bodies are there, joints are there, force elements, and wheel rail contacts. Okay, which together represent the physical behavior of any rail vehicle. So this so the motion of the vehicle is considered and guided by the rails. And Simpack has access to the whole powerful Simpack technology and all library elements. So this means that the Simpack Rail vehicle model is not limited or simplified tool, but has access full access to complete Simpack multibody simulation environment. And library means it has so Simpack provides a wide range of predefined validated elements such as like joints are there, means revolute joints, prismatic joints, spherical joints. Then force elements are there, like for springs and dampers, bushing and air springs, we use force elements. Then for wheel sets, bogies, suspension components. Okay, so these are the some library elements. So Simpack is compatible with all other Simpack products like drivetrain module is there, flexible bodies, and DOE means design of experiments. Okay, if you want to include flexible bodies, so that is also possible. We also have design of experiments. Then it has additional modeling elements like detailed coil spring models, then air spring system with pipe connections, level control valves, elastomer springs, lip springs, and contact like 2D and 3D contacts and friction elements. Okay, next we will discuss the typical applications of this Simpack, like a critical speed application. First is a critical speed calculation. Okay, so here critical speed means what? So due to the conicity of the wheels, the rail vehicles have a tendency to oscillate laterally. Okay, up to a particular speed, the lateral oscillations are stable and damped, fading out over the time. So above particular speed, the oscillations are no longer damped out, becoming unstable and growing in magnitude until the flange contact occurs. So this phenomena is known as hunting and can cause damage to the track and vehicle, presenting a derailment risk. And the speed at which this starts to occur known as a critical speed. And we have two methods for calculating the critical speed, like linear and non-linear analysis. Okay, so in linear, that is useful for the initial design phases. Means in the linear method, we run our vehicle at different speeds. Okay, we have design of experiment module, so we will run at our different speeds and we will plot the frequency versus damping, means root locus of the frequency versus damping, and then we will check at what speed the damping is negative. So then we can say that that is a critical speed. So in the non-linear analysis, we do means we run the vehicle with higher speed. Okay, and then we will apply some braking force, and then we will check means at what speed it is means what is the critical speed by doing some post processing. So next is a derailment analysis. So in derailment analysis in Simpack, the Y by Q coefficient is checked because it is a key safety indicator for the flange climb derailment. So critical use cases are defined to ensure that derailment will most likely not occur. Okay, so Y means the force between the wheel and rail, means lateral force, and Q is the vertical force. Okay, Y is the lateral force and Q is the vertical force. And according to EN 14363, the vehicle has to run through a twist between the two bogies, and an additional twist is applied between the wheel sets of the first bogie. See, we will just include one means irregularity into track. Okay, at the suppose, for example, at the left side of the rail, we will include some twist or some irregularity. Then we will run our vehicle. We will define some curvature here as per the standard. Okay, we will run the vehicle with some speed, and then we will plot this Y by Q coefficient. Here we can see here, and then we will check whether it is under below limit or not. So this red color line is the limit line. So next is a comfort ride index. So comfort in analysis in Simpack is performed to evaluate the how comfortable a ride feels to passengers when the rail vehicle runs on a given track at a certain speed. So it focuses on the vibrations and accelerations transmitted to the vehicle body, which directly affect the human comfort. Okay, so we have there one comfort filter in Simpack. So by applying some filters, comfort filter and some other filters, we will get these types of ride indexes in XYZ direction, and this combined index also we can calculate here. Like here we can see here 1.33 is the ride index here. Okay, to determine means comfort index, or to determine an estimation of the comfort, acceleration information is required. So how can we measure this acceleration? So there are three ways possible to calculate the acceleration, like with the sensor element, then with the control element 167, and with result element 167. So these elements are available in Simpack. Means we can measure accelerations through these elements, three elements. Or one more option, like if you have measured accelerations directly, then you can directly import those measured accelerations into Simpack, and you can go for the ride comfort index calculation or this analysis. Next is the roll coefficient. So this roll coefficient, according to EN14363, is calculated with this formula, like car body track divided by the track ground. So this is the car body track angle, and this is the car body track ground. So then next are the add-on models like Simpack Rail wear. So wear and material removal is calculated from the rail wheel contact outputs. Okay, and so there are two methods available, like Archer wear law and Cross Paul wear law. Okay, so two methods are available for calculating the rail wear, like wear of the rail and wheel. Both we can go. Next add-on model is the Simpack Flex track or flexible track. So we can import the flexible track from the FE software. Like it is useful for the new track designs, or it is useful for the bridges, then turnouts and crossings. Okay. So from the FE software like Abacus or any other FE software, we can import the this flexible tracks. Okay. So next we will discuss why do customers choose Simpack Rail. So there are challenges, like Simpack can handle numerically and physically large models, means up to 2000 plus degrees of freedom, and many of them are strongly non-linear. So these coaches, trucks, axles, wheels, and suspension appears multiple times in Simpack. Okay, they can appear multiple times, and Simpack can handle long trains, long tracks. So there is a demanding Simpack can handle demanding rail wheel contact, like non-linear and very steep contact is there, like 5 into 10 raised to stiffness is of 5 into 10 raised to 8 Newton per meter, and it can handle small contact areas and wheel load of the hundreds of the kilonewton. So next is avoiding redundancy. Like here we can see substructures. Substructures are nothing but the Simpack models, which are referenced by the file name. Okay, so we can have unlimited number of the substructures and nesting levels. Now we see here wheel set. We will start for modeling this railway vehicle. We will start with the modeling of the wheel set. Okay, first we will start with the wheel set here, and that wheel set model we will use as a substructure in this bogie. Okay, so this wheel set model is used as a substructure twice in this bogie. Then this bogie we will use as a substructure in this car body or coach. Okay, so bogie will be used as a twice as a substructure in this car. Then we will use coupler element here to form the train. Okay, so there is means you see in this case now this wheel set appears multiple times here. This bogie appears multiple times, right? These car bodies are multiple times. So in this case, if we want to change any parameter of this wheel set or any other parameter of this bogie, then what you have to do is that original wheel set model. You have to do the changes in the original wheel set model, and that is applicable to all the wheel sets. Okay, so that is applicable to all the wheel sets. So this is quite unique in the MBS world. So next is the rail wheel contact modeling. So there are two contacts, like standard and advanced contacts are there. Like standard is the equivalent elastic contact, and advanced is the discrete elastic contact. So equivalent elastic contact, it will determines the actual contact patch shapes, but do not use them directly or for normal or tangential force calculations. So it will convert the contact patch shape into the equivalent ellipse, which is comparable in area, and produces the forces comparable to the actual contact patch. So while here the discrete contact, it will use the actual contact, it will use the actual patch shapes for the normal and tangential force calculations. And contact search splits the profile into a number of longitudinal slices of constant width. So the contact search is performed for each slice in the local normal direction of the rail profile. So next is the track definition. So here a vehicle can run on different tracks from short segments up to several kilometers. Okay, means we can include the tracks from the short segments up to several kilometers. Then the track layout and irregularities, we can include the track layout and irregularities. Like various models and methods are available for the track layouts and track irregularities. So track layouts can be modeled via direct input or from the measured data, right? So track layouts, like we have some in Simpack, we can model track layouts via direct input, like we have horizontal segment, circular, okay, some other segments are there. So we can model that, or if we have measured track data, so directly we can input that into Simpack. Okay, we can import that measured track data into Simpack. So we can also model the track defects. Also, we can model the variable rail profiles and for the turnouts and crossings in Simpack. So there are no limitations in what you model. Like here we can see the setup of wheels. So Simpack allows an arbitrary setup for the modeling wheels and connect them to the rest of the model. So you can see first is a fixed wheel set. Fixed wheel set means what? This axle, okay, wheel axle, and two wheels are the one body. Then second setup is axle, and this wheels will rotate independently. Okay, so these two wheels are the three separate bodies, and wheels can rotate the independently. So this blue color, you can see these are the joints here. Next is arbitrary mechanism. So only one wheel, a connection body, and a separate wheel carrier. So this kind of arbitrary mechanism is used in this type of application. You can see here in this animation. Then next is a wheel alone, like a wheel carrier is equal to wheel in one body. Then arbitrary mechanism 2 is there. So on both sides, it is this mechanism will be there. Okay, wheels in the horizontal position on both sides. So this kind of mechanism can be used for the roller coaster setups. Then setup of rails. So rails can be built up arbitrarily, like so different setups are there. Like first is inertia fixed rails. So here we can see rail body is equal to inertia. Okay, means it is fixed to inertial coordinate system. Then both rails as one common ballast mass, that is one body. Okay, both rails will be as modeled as one body or one common ballast mass. Then third is each rail is a separate body, so you can model each rail as a separate body. And fourth is the roller rig setups. Okay, so roller rig, like both rails are one common roller rig body. Fourth setup, which you can see here, both rails are one common roller body. So this is a roller rig setup. Then for fifth setup is a roller rig, means each rail is a separate body here. Okay, then the sixth is more than two rails profiles in the same model. If you have more than two rail profiles in the same model, so like upper and lower profile for the roller coaster example, so we can model that into this Simpack. Then why means this there are suspension elements, like detailed coil spring models are there for this railway vehicle. Then air spring with pipe connections, level control and valves are there. Okay, elastomer springs are there, lip springs are there, and contact 2D and 3D and friction elements are there. Again, in Simpack, it has a standard library of the wheel profile and rail profiles. Okay, also user can import their own wheel and rail profiles. So they have to convert means that data into some standard Simpack readable file format, and they have to import it into Simpack. Okay, so Simpack competitive landscapes, it is comparison to other competitive MBS solutions. We can see means Adams is there, okay, VL motion is there, Recurdyne is there, motion solved from the Altair. So these are the competitive competitors to Simpack. Then again, car maker is there, Car Siemens, this V Dyna. So in this, see in Simpack, if you see here, so Simpack and all other software, they have all these capabilities. Like Simpack is a universal MBS solution. Then Simpack has flexible body support. So Simpack has high fidelity modeling. Like Simpack is having some high fidelity modeling elements, like bearing is there, gear modelings are there, and then suspension elements which we have seen in the railway vehicles. Okay, so contact modeling is there. So like some standard modeling elements are there in the Simpack. Then high frequency result accuracy, solar efficiency and stability, cross application model compatibility. So Simpack is better than its competitors in these areas. Okay, so it has best industry specific solutions, basic real time solutions, and it has high end real time capability. Okay. Usually in automotive, this real-time capability we see that means with some physical devices like steering and some acceleration, like accelerator pedal, brake pedal. Okay, some other physical devices so, that a user can give the input to the Simpack car model. Okay, and like that, user can directly provide input by that physical devices to the car model, and then he can analyze that car vehicle. So that is called as a real-time capability. So it has high-end real-time capability. So this highlighted by yellow color. So its impact is better than its competitors in these areas.
First of all, I would like to thank you, Anand, for delivering a very insightful webinar. I'm sure the audience has benefited from this presentation. In case of any other queries or questions related to Simpack or any other simulation requirements, you can reach out to us. Our contacts are displayed on your screen right now. You can either mail us or contact us, and we'll be happy to address your queries. I would like to thank once again Anand for delivering this presentation. I would like to thank the audience also for sparing their time out and joining this session. Please do keep an eye out for our upcoming webinars and seminars. We shall see you at the next session. Thank you.